Good morning, afternoon, or evening, and welcome to lesson 9.1 here for CTM and anybody else who might be watching. We are starting our chapter on geometry. A bit of a review if you're a CTM student of geometry, and you can see here, woo doggy, goodness, that is a lot of vocabulary right there. So if you're a former geometry student, these terms, though, you look at these, they should all make sense, or they should all be familiar. And if you find any here that aren't familiar and you're still not sure what they are after we get done with this, please look them up, please find them, and refamiliarize yourself with them. If you're new to geometry, you might want to get yourself familiar with a lot of these terms before we check this out. We are going to define and talk about pretty much all of these, or at least most of these terms, within the context of these notes though. So let's get started, and let's talk about, first of all, just some descriptions of some things. We won't do an example until a little bit later. So, description. We'll be drawing lots of pictures with this chapter. Geometry, it's just the nature of the beast, you could say. You need to draw pictures with geometry. Geometry is the study of points, lines, planes, angles, three-dimensional objects, etc. It's the study of things in real life. Of pictures sometimes we use to represent things, of things we can actually measure. So line AB, that's my first thing I want to draw a picture of. So if I have 2 points A and B, and I say that there's a line between them, a line is one of those things we call undefined terms. These are just things we have this intuitive knowledge of, but we actually have to not technically define them, because you have to start somewhere. If you look up a word in a dictionary, it's defined by other words, and so you have to kind of have this sense of at least some basic words, what they are, without actually defining them. That's why we call these undefined terms. And then the symbol for this line, we can write it with the letters A and B. You could also say BA. You could flip-flop these two around and it would be the same line, because that line goes through both of these. No matter if you start at B and think about it going in both directions that way, or start at A, think about it going in both directions that way. They're both the same line. So it's like that with a little miniature line above there. And then from there, we'll talk about ray AB. We'll talk about ray BA. And there's actually a difference here. Line BA would be the same as line AB, but there's a difference with those things. And then segment AB, and I think I had made another page with that. Nope, I might have to make one more page there. Yep, I'm going to have to make one more page after this, but let's do these three first. So ray AB, a ray is something that starts at that first point that's given. That's the initial point of the ray, and it goes through the second point and keeps going in that same direction. So here's ray AB, and you have to label this like this, with the A coming first and then the B coming second. So here it's saying it's starting at A and going through B. Ray BA, however, would start at B. I'm going to keep the points in the same spots as before. This would start at B and go through A. But notice that when I write the symbol for it, I don't point the arrow in the other direction. This could be pointing in any direction. I always point the arrow with the symbol to the right. That's just how it is done. So make sure you're always pointing with the symbol, always pointing to the right, but the first letter is always your initial point, where you're starting and you're going through the other point. And then ray, or segment AB would be these two, just connected like that. Sometimes you might hear this called line segment. So let's write that in there too, or line segment AB. Segment AB, line segment AB mean the same thing. And so that symbol, all the symbols match up very nicely, I think. This has one arrow, just like a ray does. This has no arrows, just like a segment does. And then the line has 2 arrows. Plane, now we're talking 2 dimensions. Plane ABC, to define or to have a line, you need 2 points. You need to connect those 2 points, at least 2 points. For a plane, you need to have at least 3 non-collinear points. Non-collinear would mean not on the same line. Collinear would mean on the same line. So hopefully some terms you remember if geometry was a course you took and passed already. Geometry is new for you. This is a good introduction lesson to some of the basic things you'll see in geometry. So A, B, and C. Here's three non-collinear points. There's really no symbol for this. You would just say plane A, B, C. And there's no symbol that I'm aware of that has been accepted by the general mathematics community. I'm going to have to insert a page after this. Okay, and so let's finish up the thought there. We're just having one more here, angle. Angle ABC. So angle ABC, if I had 3 points like this, I call this one A, B here, and C here. If I had 3 points like that, the angle with the first letter here, you would start there, go to that second point. That point's called the vertex, and then you'd go to the third point. But that middle point being the vertex, the rays, there's going to be rays coming out of that vertex going through the other 2 points. So you can call this angle A, B, C, or you could call it angle C, B, A. Both of those angles are exactly the same. So this is also written as angle CBA. Could you say BAC? No, that would be here to here to here. That would be this angle right here, which is a very different angle than what you see here. But CBA would work. And the symbol for that you're going to see like this. Or you could write it like this. Now the CTM book also includes a little something like this. So if you want to include this, I'm going to erase this after I write it here. But if you want to put a little something like that, that's fine. I think that might even be a better way to write it in case you're going to get this confused, the angle symbol with the less than symbol. But remember, angle symbols should be exactly horizontal here, and then this is about a 45-degree angle. But for the most part, I've taught geometry for quite a while here, and generally we leave that out in the geometry books I've seen. But again, if you want to include that in there like that, I'm totally fine with that. I messed up this part here, right, though. There should be an angle symbol right there. So, or angle CBA. So moving on from there, let's check out our first example. So I'm going to get out my straight line tools here. I want to make some nice straight lines. And I would say take a ruler, something to draw a straight line with, maybe the edge of your ID if you don't have a ruler handy. And we're going to draw 4 straight lines, and they're all going to intersect at the same points. And draw the arrows and each one just to designate that those continue on forever and ever and ever in those directions. And then from here we're going to label some points in the picture. So when I draw in the dot, that's what I'm referring to. W is that particular point right here. Point actually has no dimensions whatsoever. It's just that location in space. And so I could draw a point like this, I could draw a point like, don't draw this other stuff, but I could draw a point like this, I could draw a point like that, I could draw it so small you can't even see it, but it's still referring to that same idea. It's a location in space, or location on the plane in this particular case. The plane being our piece of paper or my screen. So this is kind of a two-dimensional type thing right here. So I'm going to go with these letters here. And oftentimes when I do geometry, I just think it makes it more fun when I try to spell things. So I'm going to do that here. This is I and N. It's going to have an extra E, but I don't want to have 2 of the same letter, so I'm just going to leave that extra E out. And that's, you see what that spells? Woo, that's right. There's my team. There it is. And Wolverine's, that is a rabid Wolverine right there. Literally, he has foam coming out of his mouth. Wolverines are tough little animals. They're pretty small, but they are not something you want to mess with. They will just go after things, especially a rabid one. Ugh. Okay, so using the diagram below, we're going to have different parts to this problem. So let's determine, this is going to go back to our set theory chapter a little bit. We're going to use the idea of intersections and unions and just see that we understand what I mean by these things here. So that wasn't writing very nicely there. That's a little better. So ray OS and the intersection of that with ray RS. And so on the picture, don't draw this in. I'll use green, but just kind of think about what I'm doing here. I'm just going to talk about what the intersection would be, but don't draw the stuff on the picture. It's just too much. We're going to have different parts here, and I don't want you to draw. So just listen to this part. But ray OS would be that. I think a highlighter would be actually really a good thing to use here. Then you can see where they actually intersect. So let's use the highlighter tool instead. So I've got ray. I'll make that a little bit bigger. Ray OS would be starting here and going in this direction that way. So it would continue on forever that way. Ray RS, I'll do that in red here. Ray RS would be this one going forever in this direction. But you'll notice from here to here is where they intersect, what they have in common. And so that is going to be what the intersection is. That's going to be ray RO. So I'm going to get rid of that stuff, but that was how we arrive at this being our answer. Or not ray RO, that was segment RO. My apologies. So segment RO, you could also say segment OR would be the same thing. Part B, let's say we had OS, ray OS, and that in the union now of RS. You go back to what we just had. The union is everything in either color. So let's go back to what I just had there. I had this in one color, and I had this in another color. I think I had those colors flip-flopped before, but that's fine. And so the union is in either one. It's including the intersection, but also stuff that's in just the one color. So it's everything. And so this would be the whole line right here. It would be a line instead of segment. Now it would be line RO. Or you could say line OR. That would be the same thing. How about this? If I said angle ISO, and again, make sure this doesn't look like a less than sign. If you want to add that little extra mark there, that is fine too. Take it either way. I'm just very used to having that without the angles, the extra little line, the extra little arc there from teaching geometry course that I have been using ever since I started teaching, at least out here in California. It's the one that uses the one that does not use the arc symbol in our book. But ISO, now let's use our highlighter again. Just listen again for this part, the highlighting stuff, just listen to that stuff. And this would be this angle. Now this is going on forever in these directions here. And the intersection of that and ESV. So ESV is this right here. That's going on in that direction and that direction. What they have in common is just that point right there. That's point S. And so get rid of all that and have that as our answer. So S, you can just say S, or you can say, if you actually said point S, that would be totally fine as well. D, let's say we had the line WE. So the intersection of that line and angle ESV, what would that be? So where's the line? I'll use green and red this time instead. So here's the line W, that's not green. Green, there we go. Line WE is this one. And angle ESV. Angle ESV is this right here. So it's saying intersection. What do they have in common? Well, I noticed that the parts that are colored in both highlighted parts are right here, from here to here. So I've got this in common from S through E. They both are sharing that. So therefore our answer is right there. It is SE, ray, SE. And more, there we go. It can't be written as ray ES because that would start at E and go through S. This direction we got to start at S and go through E. So rays are really the only ones you can't write backwards. And E, you have SO, ray SO, and ray SV. I'm going to say the union of those two things. What would that equal? So let's take our highlighter again. Here's SO right here. Still want to use the green to start though. There we go. So SO and SV. So their intersection would be right here, just that point, but this is talking union, so it's in either one. In either color, you put them all together, put it all together, you have this particular angle, and so we would say that the answer to this one is angle, and that was OSV. That was that angle right there. You could say that, or you could say angle VSO would be totally fine as well. And remember, again, you can flip flop these two letters, you can flip flop these two, but not these two, just not with the rays. And the book also talks about some things called it talks about half planes. We might be getting into that later in this, but it talks about half lines, and that's not really something that comes up in most geometry courses, half lines, what those are. But if you want to check that out and find out what that is, feel free to look in your book and see what it is. It's basically like an array, but it's got an open circle at one spot. Did I do that? Yeah, that's the way I wanted to do that. Okay, I thought for a moment that I had my template off, but nope, we're good. So types of angles here. Let's put that off to the side over here. These are types of angles. This is a really good review of some of the first things you see, I would say, in the first like 3 chapters. There is, because of just the amount it's covering, there's a lot of terminology here that hopefully is familiar to you, but good to review it here. So a right angle, what's that look like? Well, that looks like this. And we can put a little box in the corner right here, and then let's get out our different color at this point and put this in a different color. So right there, from there to there, if I call that X, that measure from here to here, then X would equal 90 degrees. Let's put the X stuff in our different color. So the angle itself will draw in black, and the X things I will put in my red color. You use whatever color you're using. So acute. Acute is, if you remember, that's something that's less than 90, and so here would be an acute angle, an example of an acute angle. This would be 0 degrees is less than X. Notice the difference here between this and the angle symbol. Angle symbol, again, going down 45 degrees and then straight across horizontally. The less than symbol, it's kind of like at 45 up, 45 down degrees like that. So just be careful with that. Make sure I can tell the difference. This would be 0 degrees and 90 degrees. X is in between that, but not including. You can have a 0 angle, but it's not really, I don't think, interesting enough to even write down here. 0 angle has a measure of, guess what? 0 degrees. Okay, here's an obtuse angle. This one is just bigger than 90, but it also has to be less than 180. So if this is your measurement here, I'll put that on the inside. I meant to do that over here, but no big deal, no biggie. We got 90 degrees here and 180 degrees here. With obtuse, it's in between 90 and 180. And with a straight angle, think of a straight line. It's the same thing. You got a straight line. The angle itself here, from here to here, calling that X, that would be X would be equal to 180 degrees. If you go all the way around in a circle, that's 360. Alright, so that's good for a little introduction or recap review of those things. So now let's say that this was the case, that DUC and KUC are adjacent and complementary. And the measure of angle KUC is 21 degrees greater than the measure of angle DUC. We'll draw a diagram. and determine the measure of each angle. So a couple of terms that you might not remember, might not be familiar with. Adjacent, first of all, what is that in terms of angles? And complementary, what is that? So adjacent, that just means kind of right next to is a kind of a loose way to think about that, but a more technical way is that they share a common vertex. So a vertex is like this part of the angle right here, where the rays come together, where they meet and kind of shoot out of from there. So a common vertex, and they also share a common side, so share a common vertex and side, but no interior points. So we'll draw the picture and talk a little bit about how that relates to the picture. So interior points would just be the points inside, in a sense, in the angle. So I would shade this part. That would be the interior of the obtuse angle. Shade this part, the interior of the acute angle. Complementary just means that they add to 90 degrees. So two angles that add to 90, we call those complementary. So let's draw a picture of this situation. They're supposed to be complementary. It's supposed to add to 90. So I'm going to draw a 90-degree angle in freehand. That's a little curving out that way. Let me try to do a little better drawing there. I'll go straight down. Try and do this freehand though, like I imagine you are. So that's 90 degrees, but there's two of them. One of them is a little bit bigger. One of them is 21 degrees bigger, so I'm going to try to draw one bigger than the other one by about 21 degrees. Remember, they add up to 90 here. So we can, let's do that. Let's put a little box in the corner. The whole thing is going to be 90, but this part is going to be x plus 21. If I were to call this part x, this one would be 21 degrees greater. And so what's what? DUC, it says, is we got KUC is 21 degrees greater. So KUC is the larger angle than compared to DUC. And so I have to have DUC being the smaller one and KUC being the bigger one. They both have C in them, so C would need to be right here, not here or here, because they both share that point with their angles. So this could be KU and C, and this could be D, U and C. And so that right there is a good diagram, a solid diagram with information that I've given here. So from there, hopefully it's a little easier to see how we could solve this. But here's our solution. Let's say let x equal the measure of angle DUC. So first tell me what your variables are representing, and then we can set up our equation. We can say that DUC plus KUC, or KUC plus DUC. The order of those two doesn't really matter. That plus that would have to equal 90 degrees since they're complementary, since they add to 90. Let's make a little arrow here just pointing right to there. That's where that came from. And then we can replace now what I have in the picture over here with the equation. So KUC, that is x plus 21, and DUC, that is x. Putting those two things together, I can combine like terms. So I've got 2x plus 21 is 90. Let's use our different color to show the steps here. Subtract 21. That'll cancel. 2x equals 69 then, and divide by 2. And you got your value for x. X equals 34.5. So not done, but that's really important. That's just about got me to the end. It says, careful here, it says to draw a diagram and determine the measure of each angle. So x represents DUC. So now I can say, therefore, the measure of angle DUC, that's what I need to know. One of the things I need to know is x is 34.5 degrees. And the other one, that KUC, that's going to be x plus 21. That plus 21 would be 55, I'm sorry, 55.5 degrees. And so that's one part of our final answer. And this is the other part of our final answer. And this was just coming from 34.5 plus 21. So let me separate that there. So got to this first, and then therefore that and that are the angle measures are. From there, let's do one more similar to that. These tend to be a little trickier for some people. So let's use one now where we use the word supplementary instead of complementary. You'll see if you remember what the difference is between those two things. So let's suppose that lin and oil, maybe once this video gets older, you might not recognize that guy. You might even not recognize him now if you're not an NBA fan. But Jeremy Lin, we had Linsanity happening a little while ago when he used to play for the Knicks. He now plays for the Rockets, at least at the recording of this. Maybe he's on another team now if you're watching this later. But Jeremy Lin and oil, he was just in fuego. He was on fire for a couple of weeks there and made the cover of Sports Illustrated. Came out of nowhere, came out of Harvard, and just started playing like crazy. Got a solid contract, and now he's starting point guard for the Houston Rockets instead. So he's doing pretty good. Hopefully, I like the guy. I hope he's an all-star pretty soon. He's getting better little by little. So let's suppose lin and oil are supplementary, and that the measure of angle lin, L-I-N, is 8 times greater than measure of angle oil. Let's suppose that's the case. And now let's draw a diagram and determine the measure of each angle. So since they're supplementary, well, what does that mean again? Supplementary just means they add to 180. How I keep these two things straight, my students that I've had in the past have had some clever ways too, but I think the easiest way, at least for me, is just thinking complementary. C comes before S, and 90 comes before 180. So just keep them in order. 90 goes with the complementary, and 180 goes with the supplementary because C comes before S. There's other ways. If you come up with a clever way, perhaps you can tell me, and I can share that with some other students. Maybe that'll help them remember what's what. Always good to come up with little mnemonic devices to help you remember things in math or any class for that matter. And so it says one is 8 times greater than the other. This is not quite to scale, but if I called this one x degrees, this one would have to be 8x degrees. It would have to be 8 times bigger than that. And so here's the bigger one, here's the smaller one. Definitely acute, definitely obtuse here. They're adding to 180, so they make a straight line together. And how would I have to do this? It looks like I is the vertex for both those angles, so I must be where they intersect right here. And then lin and oil are the angles. So L would have to be the part they have in common, the side that they share, because that's in both of these. And then I could say that this is, I'll go with that. It says that lin is 8 times greater, so this has to be the bigger angle. So I could put that there, the N, and I would put the O over here. So there's my diagram, and here's how I'm going to go about solving that. So what did we say? We said that X was going to equal the measure of angle oil. If that's the case, then measure of angle lin plus the measure of angle oil. Before we had it equal to 90, now it's supplementary. Now that it's going to equal 180 degrees. So back here, it's complementary, it's adding to 90. Here now it's supplementary, adding to 180. So let's use our color, let's point to that right there. That's where that came from. And now replace it with what they are equal to. So this is going to be 8x, the lin part, and then the oil part is going to be x. You put it together, and you've got 180. So that's 9x equals 180. Let's show our steps to finish off in that color. We've got dividing by 9. That'll cancel. You'll have x is equal to 20. Now again, not our final answer, but very important piece of information. We still have to determine the measure of each angle. So the measure of angle oil would be the easier one, because that's just equal to x. So I'm going to say therefore the measure of oil equals 20 degrees. And the measure of angle lin is equal to, that would be 8 times 20, which is 160 degrees. So let's put that off to the side there, but this is my answer. And then you may have noticed, hey, it kind of spells, if you put all the letters together, it spells the best team in the NFL, or soon to be, but yeah, that's a lion. But go Lions, Detroit Lions. Yeah, that's right, I'm from Michigan originally, and that's my team. That's my boys right there. Let's go. Calvin Johnson, currently best receiver in the NFL. I think it's going to be that way for a long time. Again, I'm dating this video. Some of you may take that the wrong way. You're dating the video? That's weird. No, I'm just saying that the video is old if you're watching this years after I make it. Silly kids. Oh my gosh, I get that all the time. No. Take it in context. Okay, here we go with the next part. So I want you to draw two lines that are parallel as best you can. So these lines not crossing, and we're going to draw little arrows on them. That designates that they are parallel, that they have to be parallel. And then I'm going to have you put 1, 2, 3, 4 there, 5, 6, 7, and 8 down here. Let's call this line a cursive L. Don't use a lowercase l in print because it looks too much like a 1. So use a cursive L and then put a little 1 there. We're going to say this is line L1 and line L2, and this we're going to call line T. T is standing for transversal. Alright, so this line right here is called a transversal. Let's put that in a different color. Transversal. Because it cuts through two different lines. It goes through two different lines at two different points. And then this designates that the lines must be parallel. So let's put that in a different color. Lines are parallel. You can also use a symbol for that, which we'll see in just a moment. So let's take this over here. This will lead us into our final example in just a moment, but assuming L1, and then we'll draw that. That means is parallel to, so kind of on a slant. I've also seen some books just go straight up and down. That's fine too. Just make sure it doesn't look like an 11. Make sure if you're going straight up and down that it's a little longer than your 1s normally would be. So I think it's best because of that to put it on a slight angle there. So assume L1, and then you read that if you're reading that out loud. Assuming line L1 is parallel to, that's what you would say right there, is parallel to line L2. The following, I'm going to teach you some more symbols here. Angles are congruent, meaning they have the same measure. So this is angles. It's a short way to write that. Just make the angle symbol with an S after it. And then this is congruent. Congruent just meaning same exact measure. They're exactly the same. Equal measures. Kind of depends on the situation. What is the best context for that, or the best way to say congruent, what it's referring to. But we've got some different angles here in this picture. We have something called vertical angles, which you can abbreviate or shorten like that. Put that here, and then we've got 3 others. Alternate interior angles. Which you can just write AIA, and we'll all understand what you mean from this point forward. You can write, for alternate exterior angles, you can write AEA. And for corresponding angles, The generally accepted way to write that is, shortened way is like this. Right, corresponding and then angles like that. At least that's how we'll write it in this class. So we have vertical angles would be angles that are right across from each other. I'm going to use a highlighter here. Don't actually do the stuff here in highlighter. I'm just going to point some things out or show you what it is. So this would be this angle right here, and this angle right here would be vertical. They're right across from each other. They form two perfectly straight lines together. This one and this one are vertical. They're right across from each other, and they form two perfectly straight lines together. You can do the same thing down here with 5 and 8 and with 6 and 7. And so let's write that down. That pairs of vertical angles would be angle 1 and 4. We can say angle 1 is congruent to angle 4. We can say angle 2 is congruent to angle 3. We can also say angle 5 is congruent to angle 8, and angle 6 is congruent to angle 7. So these all go together. Those are the vertical angles. Alternate interior angles. Think of what the words actually mean. What does alternate mean? It means on alternating or opposite sides. And interior would be, think of the transversal and the interior of the two parallel lines. What's inside there would be this one and this one. So with 3, alternate interior would be on this, going down to this one. Here's the alternate one to that on the opposite side. These two would be congruent to one another. You could also say that 5 and 4 are alternate interior angles. And so let's not put that there in the picture though, just that'd be too much going on all at once. Just to clarify what that was though, that's why I was using the highlighter there. This would be 3 would be congruent to 6, and 4 would be congruent to 5. Notice congruent is like it is an equal sign with a little tilde above that. And then alternate exterior angles, very same idea, very similar idea, but now on the exterior, on the outside of the parallel lines, considering this to be the interior, this would be the exterior. So this one and this one would be congruent. And you could also say that this one and this one are congruent to one another. So those are our two pairs of alternate exterior angles. That would be angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. So these go together. These are all alternate interior. These ones go together. These are all alternate exterior. And finally, corresponding angles. Think of things that are in the same relative spot, correspond to each other. 1 would be congruent to 5. 2 would be congruent to 6. 3 to 7, and 4 to 8. Think of these as being kind of in the lower or the upper right-hand corner. The 1 and 5, upper left-hand corner, and so on. So they're in the same relative spot. As long as the lines are parallel or can be assumed to be so, we can say that those are going to work out as well. So angle 1 is congruent to angle 5, 2 to 6, 3 to 7, and 4 to 8 in this picture. So sometimes the numbers will be ordered differently, so you can't just assume that it's always 1 matching up with 5. It depends where 5 is. If 5 is actually in the matching up spot with 1, then yes, they're corresponding. So let's do one final example here where we put this into practice. I'm going to have you draw another picture, two parallel lines. We'll make these ones go, the parallel line parts, put them kind of like this, orient them like this on your paper. So parallel lines don't always have to be horizontal on the paper. They can be pointing in different directions. And let's make this one, notice this angle is a little bit bigger than this one. I want to make it even more pronounced than that. So I'll go more like that. It's not going to be drawn perfectly to scale, but something like that. So let's say here, if the measure of angle 1, which I haven't told you what that is yet, but I'll put that in there in a moment, equals 41 in the diagram, determine the remaining angle measures giving a valid reason for each. Excuse me. So where's 1? 1's going to be right here. 2 this time is going to be here. And I'm going to order them a little differently than I did here, just so that we don't think it always goes in the same order. So 1, 2, 3, 4, 5, 6, 7, and then 8 I'm going to put up there. In the different color, let's label them as we go along. I know that 1 is 41, so I'm going to put that 41 degrees right there. What could I say from there? So think about the reasons we just learned. And you can also use linear pairs are going to be supplementary. So if they form a line together, I didn't write that down, but hopefully that's something you remember, or something that's fairly obvious from just looking at the picture. 1 and 2 would be a linear pair here. They would form a straight angle together, 180 degrees together. And so we could use that here to start. So our solution, we can, that's OLN, there we go, and the measure of angle 2, you could say is 139 degrees, because that's 180 minus 41. So right here, this is 139 degrees, but what makes that true? Give me a valid reason. I'll put my valid reasons in parentheses here. It's a linear pair with angle 1. You could say that. I would also accept that it's supplementary with angle 1. So I'll put that shorthand like that. Supplementary. SUPP can stand for supplementary with angle 1. How about the measure of, let's just write the rest of them down right here. 4 through, or 2 through 8. What are the rest of them? You think we can figure out all of them just based on having 1 degree measure? Sure can. One thing I forgot to put in the picture that I meant to do, we couldn't actually assume that these are congruent or equivalent in this nature unless we know they're parallel. So let's also add that this is parallel to this. So I have to know that that's true before I could say that was the case. So otherwise I could have this line being like this. They would end up crossing. These angles definitely, like 1 and 7, even though they're corresponding, they would not have the same measure unless they're actually parallel. So from here, we've got 139 for 2. I want to try to give as many different reasons as I can. There's other ways to give reasons for some of these things. I could say 3 is going to match up with 1 because they're vertical angles. But I could also say that 2 and 3 are supplementary together. They form a linear pair. So I could use 2 different reasons on this one. I'll go with the vertical angles one though, since I haven't used that as a reason yet. But again, there's different valid reasons that will exist as we go through things here. Vertical angles, I'm going to put a comma in between these, so it's supplementary, kind of with a comma meaning with angle 1. Vertical angles with angle 1 here as well. And now let's put that in as we go. Let's label them. The more we get, the more information we have, the easier it is to finish the puzzle. I kind of think of this as I'm filling in the puzzle. What's the other missing pieces here? I know that 4, I'm going to go in order here. 4 is going to be matching up with, I could say it's matching up with 2 right here. These are corresponding. And so right here, I could say that 4 is going to equal 139. Right, so this would be, I'm just looking at my notes here. Originally I had the wrong thing in there, so that's why I do this twice. I can catch my mistakes. So this is going to be 2 and 4 corresponding. I could say these are corresponding angles. It would be corresponding with, but I'm leaving out the W, the comma is representing my with sort of here, with angle 2. Okay, these are corresponding angles. Angle 2 and angle 4 are in the same relative kind of upper left hand spot, you can think of it as. 139 is right there. Now let's go to, looks like my pad that I'm writing on might be getting a little low on battery. Yep, I'm going to have to pause this a second. And I'm back. So I'm plugged in, ready to finish this up. We've got angle 5. What could we say there? There's some different reasons I could say. Let's use a different one that we haven't used so far. So let's use something other than these 3. I noticed that 1 and 5 are on alternate sides of the transversal. They're also exterior to the parallel lines. They're on the outside of that part, so the interior is here, exterior is out here and out here. And so I could say alternate exterior angles for that one. This one and this one would have to be congruent, so that would be 41 degrees as well. And you can say AEA with angle 1. That would be a valid reason right there. Let's fill in that this would be 41 degrees then. And let's continue to try to give some different valid reasons. I'll skip down to number 7 here, angle 7. I know that this one and this one are on alternate sides of the transversal and they're interior instead. So let's use that as a reason for angle 7, that this would be 41 degrees. This would be alternate interior with angle 3 right there. So I'll fill that in. Could I have used vertical angles here and here? Sure. Linear pair here and there, supplementary instead. Same idea. Yeah, I could do that too. Is there one I haven't used? I think I've used them all, so now I'll just do whatever comes first to me, whatever I see first. Let's go with another alternate exterior angles here. 2 and 6. I see our alternate exterior. They're going to be congruent, therefore. And so I can say AEA, angle 2. And I'll write that in here. This will be 139 then. And finally right here, lots of different reasons I could give. Let's go with, why don't I do corresponding again. Corresponding with angle 6. Angle 8 and angle 6 are kind of in the lower right hand corner. In a sense, it's kind of in the right side here. So we've gotten the same relative spot. And you can say corresponding angles with angle 6. That would be a valid reason. Again, there's a lot of other valid reasons, especially as you continue going and you get close to finishing, filling in the puzzle. You've got more and more reasons that you could give, but they just have to be valid. So let's put one final note here that here other reasons also can be valid. So these aren't the only things that might work, but it does have to be a valid reason. You can't say, for instance, you couldn't say that angles 7 and 6 are corresponding. That's not true, but you could say angles 7 and 1 are corresponding. That would be true. So that will do it for this lesson. It's a good introduction, a good refresher on some of the first things you see in geometry. We are going to be hitting pretty much the basics or the broad overview of geometry in these next 4 lessons here. Next, maybe I'll do more, but for right now, for this year at least, when I'm recording these, I'm just doing the first 4 lessons in this chapter. But good overview, a good recap of geometry. It's going to be a lot of terminology to hopefully remember. Hopefully you already remember it, but just because we're basically trying to review a 1-year course in 4 lessons. So there's going to be a lot to it in terms of things you hopefully remember but might need a refresher on. So just go back and review those terms, review those definitions as needed. The ones that you maybe looked here and said, I don't remember what that is or what this means or so on. Go back and review those. There's some we didn't talk about here. We talked about, I think, some of the most important ones. We will continue to hit more of these vocabulary terms, though, as we continue with this chapter. Hopefully that helped you. Hopefully geometry review or geometry introduction, if you're just seeing geometry stuff here for the first time, will be good for you here in this video. I'm going to stop talking now. Have a good day.